Okay, welcome back, my dear friends. Today we will start off with a new chapter and a unit from the class 12 mathematics. That will be unit 4, vector algebra. And here we will do chapter 10 first, that is vectors. So we have already done matrices and determinants. Now we have decided to just start with this vectors and scalars because this unit is quite important it has two important topics, that is vector algebra, vectors, and three-dimensional geometry, which actually you can do at home and practice. That's why I just thought that maybe this might be better for you for the moment. All topics are important, but as of now. Now, we are actually very sorry that we could not upload more videos, audio classes for the past 2-3 weeks, as like we were all quite busy with the online classes and then preparing students for certain examinations, and some official works were also there. So we apologize for that, but we promise that we will continue to start uploading more videos so that you can all benefit. So now, before we really begin with the topic, I would actually suggest all of you to just have at least a pen and a paper every time, because you are here not to listen to our audios and all, but you are here to to learn. So this audio classes is not important, learning is more important. So please make sure that every time you keep your pen, paper, everything ready with you, so that you can note down the points also, okay? Because that will be very helpful, because that is also not very good always, so every time you cannot be uploading videos. Now, this topic, that is vectors and scalars. Now, without wasting time, now actually I prepared some notes roughly and made that because what I observed was that it was taking taking much longer time than I anticipated in writing down notes and then explaining point by point. So this time, just to reduce some time, because I know that online videos can be quite boring if it is too lengthy, so that's why I just noted down some points which will help us consume less time. Now, actually, what are vectors and scalars? In physics, actually in class 11 we have already done this, and science students, I believe that you will actually understand, but this video actually would be very helpful for the commerce students also, not from mathematics background also. So now, vectors and scalars. Now, what are these vectors and scalars? Now, in life we will see that there are many physical quantities, so in many physical quantities like this, length, mass, time, temperature, area, volume, all these are physical quantities. Now, what are scalars and what are vectors? Now, scalars actually are like those quantities which have only magnitude, whereas vectors are those quantities which have magnitude as well as direction, that is are called vectors. Now, magnitude means the quantity. Okay, now for example, like, what is your height? That might be a question. Now I'm talking about my height. If I just say, okay, 5 feet 10 inches or 5 feet 11 inches, that is my height, just taking my example. Another question is like, there is a table and I apply force. Now the question is, in which direction will the table be moving, because I've applied a force. So if this was the table and then I've applied the force in this towards east, then the table will move towards east. If I've applied the force towards the west, it will move towards west. So when we talk of certain physical quantities like force, then the direction is important here. But when I ask like, what is your height, then definitely no, you will never ask that person like, okay, you want my height in terms of like upar wali na niche wali, no? Above or left side or right hand side, or no, height doesn't have any direction. It's just like, okay, 5 feet 10 11 inches, that's our height. So any physical quantity where this direction is a concern, that will be called as vectors, and any physical quantity where direction is not required will be called as scalars. So keeping that in mind, all these quantities that I wrote down: length, no direction required; mass, time, temperature, area, volume, time, money, these are physical quantities which do not require any direction. So these are all like scalars. Okay, now again, for example, like speed, for example, like the best example will be, okay, that truck is moving at 20 kilometers per hour. Okay, that's like no direction, that will be just speed, because where is the truck moving, which direction, we have no idea. So that will be speed. So that's going to be a scalar quantity. When you talk of another sentence, that is, okay, the truck is moving at 20 kilometers per hour towards police point or towards town, then I'm giving you a direction also, so that will be considered as a velocity, which will be a vector quantity. Okay, but this is a physical aspect, so we're not going to be really studying in detail about okay what is scalars, what is vectors, no, because in mathematics we'll be just concerned about, we'll be just doing vector algebra, that we will be just concerned about, we'll just focus on addition, vector addition, subtraction, multiplication, so only this mathematical part, so it will be just on the vector algebra. So this is just a background which is needed, so that's why I just discussed in short. Now the question is, how do we represent a vector? Okay, representation of a vector. Now a vector in simple layman's language, I would just tell you, it is a directed line, a line which has a direction. A line that is directed is called as a vector, not a normal line, because this line that I have drawn here doesn't have a direction, but when I put a direction to it, then it becomes a vector. Now this point, starting point, is called the initial point. The point where it ends is called the terminal point. Okay, so and how do we denote? That is, if the initial point was A, final point, terminal point is B, then it will be denoted, the directed line will be given by vector AB. Now it can be also denoted by single alphabets also, vector A, in any alphabets that you wish. Now this is very important, the direction. It means that the moment I write vector AB, it means it's going from A to B, that is A is the initial point, B is the terminal point, so this is the vector. Now if I write, if B is the initial, A is the terminal, then it's going to be BA, because it means it is directed from B towards A. Now about magnitude of a vector. What do you mean by magnitude of a vector? The length of the directed line, in short, will be called as the magnitude. It is denoted by the modulus of the vector AB, or the magnitude, that will be AB. Alright, or in this denotion also. Alright. Now moving on to the next topic, that is position vector. Now what do you mean by position vector? Now for that, what I've done is I've drawn a three-dimensional axis, x, y, and z, where I've considered a point P. Now you should understand that this is done on the surface of my tablet, so it looks like a two-dimensional, but remember that this P is on the space, okay, that is like perpendicular to this line, this axis OA. So imagination is a key point in vector algebra and three-dimensional geometry. So if you lack imagination, then you will find it very difficult to solve problems. So imagination is necessary, okay, for three-dimensional, because this will be something which we cannot put on paper. Most of the part you will have to imagine points on space. So I've just drawn that a point P, x, y, z, with respect to the x-axis, the y-axis, and the z-axis. So position vector for point P is a vector whose initial point is at the origin and terminal point is at the point P, denoted by OP vector. In other words, the distance of the point P from the origin, or the position, the displacement, I would say, of the point P from the origin is called as a position vector of a given point, denoted by common letter that we use is vector R. Now how do we find out its magnitude? Okay, so its magnitude, vector R magnitude, which can be written as R or OP in simple, will be simply using the distance formula from three-dimensional geometry in class 11, that is x minus 0, because distance of the point from the origin. So we have x square plus y square plus z square, which is denoted by OP or simply R. So that's like, if I have a vector AB, then its magnitude will be simply denoted by AB, which is calculated as the modulus of the vector AB. Okay. Now the next topic will be direction cosines and direction ratios, which is going to be very important, because in three-dimensional geometry also this is a must. So let's see what we have now. If we have considered this point P, which is lying on the space. Now what happens is, remember again, I repeat, this is on space, not on the surface of the tablet. Okay, now what happens is, this line actually makes an angle alpha, let's say alpha. I'm using because you can use on other angles also, but in general we just generally use these angles, so that's why. Okay, you should not think that okay, this is the only angle that I have to use. It can be anything, no, these are just letters denoting. Let's say it makes beta with the y-axis, it makes gamma with the z-axis. Then in simple, alpha, beta and gamma are the direction angles and their cosines. You remember now, trigonometry, and their cosines are called direction cosines, that is cos alpha, cos beta, cos gamma, which is also denoted by L, M and N, are simply called as direction cosines. So direction cosine was a simple concept, the cosines of the angle which the position vector directed line makes with respect to the x, y and z axis respectively. How do we calculate it? Now what I'll do here is I will join, let's say this is the point A, I will join this point. Now what happens is a triangle, if I cut that out and bring it here, I'll get a triangle where this is the angle which is being made by OP. Okay, this is the angle which is being made by OP with respect to A. Now PA, this will be perpendicular because this point, remember, this is on the surface. So okay, at first you might think no, that's not the case, but remember, this is not on the surface, this is on space. Now if I like, if this comes on the space, it's going to be definitely perpendicular. Okay, perpendicular, I cannot show it here, okay, even if I want. So it's like that's why I meant, no, you have to imagine. Okay, so there's a but, this point will be like on the space, that is right on top of the axis OA, I mean x-axis. So this will be like this, OP will be perpendicular to OA, and this will be making an angle alpha with the x-axis, this angle. All right, so that is this angle OA and OP. No, OA is making an angle alpha with respect to the x-axis, but this point will be somewhere like, let's just imagine like this, no, here, something like this, no, perpendicular. Now I think it looks okay, slightly okay now, but still, then remember, this is imagination only. All right, now if we use now what is OA? OA, this is x that I've written before, right? So this will be x. Now how do we calculate cosine? Cosine of an angle, that is like base by the hypotenuse OP. Now OA is x, OP is what? OP is the position vector, so it will be magnitude of the position vector. So now how do we calculate OP? As we had seen here, and just at this point, that is simply x square plus y square plus z square. So that means L will be x by x square plus y square plus z square. M will be similarly y by, I'll just write here, magnitude of the position vector, which is same actually. Okay, magnitude of the position vector. So these are called as direction cosines. Moving on, what are direction ratios? Now in short, direction ratios are numbers A, B and C, okay, such that this is the condition, they are proportional to the direction cosines. All right, so these are called direction ratios. Certain numbers A, B and C, which condition should be that they should be proportional to, proportional we all know, we've studied in our lower classes, proportional to direction cosines. That is, A by L should be proportional to B by M, C by N. They should all be, for example, let's say it's K. Okay, so they should all be proportional to the direction ratios, should be proportional to the direction cosines. All right, so I'll not go into calculating how we calculate the direction ratios and direction cosines, but I'll just talk about the conditions only. So these are called as direction cosines. All right, I hope that is understood. Now, for example, for a specific point like P, X, Y, Z, that is line, then OP we know how do we calculate, and we'll learn again, that we'll discuss in the other topics. I'll just discuss about here. Then the direction ratios, okay, direction ratios of OP will be X, Y and Z. All right, this is like only in case of a point. All right, so that's here we are just discussing about a point only, not a vector which is joined formed by joining 2 points A and B. In that case, the direction ratios will be different, the way we calculate will be different. We'll soon come to learn about that in the upcoming videos also. So since here we are just discussing about a single point, for a point what happens is direction ratios is almost it's all same as the coordinates only, x, y and z. But I repeat again, that happens only for a point, because in slopes also you may have studied in two-dimensional geometry also, but case will be different when the vector is actually formed by joining 2 points, that is vector AB. Like for example, this is the dimensional space, we have a vector AB, so that's going to be vector A. So the direction ratio of this vector will be quite different from the origin, because there OA, OB will be involved. So that we will learn again when the topic arises. So without confusing you much, let us just keep it here for now. Okay, so direction ratios for a point is simply the coordinate itself, x, y and z. All right, now that's why of course you can see here, no, x direction cosines, direction ratios. Again, we will calculate more about we will study about that. Okay, now a note that is like a direction ratios relation among direction cosines is L square plus M square plus N square equal to 1. So I will not go for the proof of this. It is quite simple, but we will not go for the proof of this. Okay, but we have, okay, let me just give you in short, no, x by r, r means magnitude, we have learned that, m y by r and z by r. So if you just go for the square, x l square plus m square plus n square, it's going to be, I will just do it directly, okay, without taking the LCM. So that is simply square of r, because r was x square plus y square plus z square, so r square will be square of this. So that's how we get this proof 1. All right, so that is what we have about direction ratios and direction cosines. Now very quickly we will study about the types of vectors. What are the types of vectors that we have? First one is zero vectors. What is a zero vector? Simple, where it's a vector whose magnitude is 0. Yes, it can happen. Okay, a vector whose magnitude can be, of course, 0. That can also happen. That means its length will be 0. Maybe a point where 2-3 vectors meet. So any vector whose magnitude is 0 will be called as a zero vector. We will discuss about this more again, okay, in the next topics. I just want to save some time, so I'll just give you in brief, I'll just discuss the different types of vectors. Now unit vectors. Now what are unit vectors? Vectors those whose magnitude is 1 unit. Okay, not 1. Okay, not vectors which is like 1. It's about vectors whose magnitude is 1 unit. For example, the distance of my home, the school. For example, like distance of your school from your home is like say 1 kilometer. So then this is my unit vector. But if the unit changes, like the same, if you change it to like meter, so that will be 1000 meters. So in that case, unit vector will be 1 meter. So I hope you have understood that concept. No, it's about 1 unit. All right, so that will be different in different cases. So it's simply about a unit vector whose magnitude is 1. That's our concern here. Now denoted, usually, suppose if this is a vector A, then it's usually denoted, unit vector is denoted by A cap, and that is actually calculated by a vector of A divided by its magnitude. That means like the full length, we are breaking it into unit vectors, that is 1000 meter into 1000 parts of 1 meter each. So total vector divided by its magnitude. That's how we calculate unit vectors. Now next, co-initial vectors. Co-initial vectors are those vectors which have like same initial point. Like for example, no, vectors which have the same, this is the initial point, which have the same initial point. Next, equal vectors. So that's quite simple. Equal vectors, vectors which are equal in magnitude as well as direction, but that doesn't mean that it will be this. Like if this is my vector AB, then the other vector can be like here also, PQ. As long as they are in the same direction with the same magnitude, then they will be simply called as equal vectors. Okay, negative vectors. What are negative vectors? The negative of a given vector is simply called as negative vector. In other words, when you talk of direction, opposite direction but same magnitude. Same magnitude. For example, this is one vector OA, then its opposite direction, no, OA, then this will be called as its magnitude, negative of this vector. So negative of vector A will be minus of A. All right, so just in the opposite direction. Next, of course, we will discuss about, let's say, like vectors. Okay, now like vectors and unlike vectors. Now what are like vectors? Like vectors, collinear vectors. Okay, before that, what are collinear vectors? Collinear vectors are vectors having the same or parallel supports are known as collinear vectors. Not necessarily lying on the same line. All right, maybe parallel vectors. Yeah, these two can be called as collinear vectors. That's why vectors having the same or parallel supports are called collinear vectors. Now what are like and unlike? That will be number 6. So this will be, sorry for that, I just skipped that collinear vectors. I did not know about that. So next will be like 7, that are, I'll just compile both of them, like and unlike vectors. Now like and unlike vectors, these are not equal vectors. Okay, like vectors are those vectors which have like same collinear vectors, same direction are called like vectors, and collinear vectors are like opposite direction are called unlike vectors. So collinear vectors with same direction are called like vectors. Collinear vectors with opposite direction are called unlike vectors. Now I'm not giving you the definitions and write-ups because you will all have your textbook, so your textbook also will help you a lot. So the notes and all, you can of course get it from the textbook. All right, so now this is what we have with vectors. So this is the general concept. Now if we just take one, let's say one example, that is, let's say this example will help you. Okay, so let's say A, B, C, D. So maybe in this direction, this vector in this direction, this vector in this direction, this vector in this directions. So now let's say I'll just name randomly A, B, C. I'll just name it randomly. Okay, A, B, C, D. So now here, if we see, what are co-initial vectors? Co-initial vectors are vector A, vector D, because they have the same co-initial point, right? Next is equal vectors. What will be equal vectors? That will be like vector D, vector B, because they will be like parallel. Imagining this as a square. Vector A, vector C. No, this will be not equal vectors. Equal vectors will be vector D and vector B, because parallel vectors, and equal in magnitude also, because we are considering a square. Negative vectors will be like vector A and vector C. No, because this will be negative vectors, because they are of the same magnitude in opposite directions. All right, collinear vectors. Collinear vectors are parallel vectors, that is vector A and vector C, vector D and vector B also parallel vectors. All right, now zero vector. What will be zero vectors? That's why I told you. Now zero vectors like a vector, this is a zero vector. Okay, that can happen also. Okay, this also are possibilities. B vector, right? These are called as zero vectors. C vector, D vector. So these are called as zero vectors, and here magnitude is going to be 0. So that's what we have with vectors here. These are just some basic. I've just tried to keep it as short as possible, so I might have been a little bit quick in the in my language and all, so please bear with that. I actually wanted to just do one because I did not want to skip into two topics for the same concept, so I just wanted to summarize into one video only, just for one concept. So in the next coming up exercise, we will learn more about matrix again, vectors, their additions, different kinds of vector product, dot product, cross product, and also please stay tuned and log in for more videos. And I believe that our videos are actually helping you a lot, so please do comment, and if you have liked this video, please do comment below, and then if there are any doubts and queries, please use the comment section, and then you can tell us your problems, and we will definitely help you. And then if there have been any mistakes in the language and all, please we request your pardon for that. We will be looking into it also. All right, then, see you, stay safe, and happy studies. Thank you.